Okay, chapter 1, section 3 is on trigonometric functions. Just a reminder, the Pythagorean theorem deals with right triangles. It's a squared plus b squared equals c squared, and we're going to see a manipulation of this throughout this section. And the distance formula is d equals the square root of x2 minus x1 squared plus the quantity of y2 minus y1 squared. Trig functions combine the distance formula with the Pythagorean theorem. So this is our manipulation of the Pythagorean theorem. R, which is technically c, equals the square root of x squared plus y squared. If you want to see it like the Pythagorean theorem, technically this is just solving for r. You will see this pop up a lot throughout this whole year. X squared plus y squared equals r squared. It is the Pythagorean theorem. It is just using different letters. These are your trig ratios or your trig functions. The sine is the value of y over r. The cosine is the value of x over the value of r. And the tangent is the value of y over the value of x. And these are your reciprocals. So cosecant goes with sine. It's the value of r over y, so we just flip that fraction. Secant goes with cosine, r over x. And cotangent goes with tangent, x over y. So looking at example 1, the terminal side of an angle, remember the terminal side is the side that moves. Theta, remember theta is just another version of x, passes through 815. So it's passing through this point, 815. Find the 6 trig functions. So if it's passing through the point 815, that means on my x-axis, I have gone 8 units. And technically, on my y-axis, I've gone 15 units. So x equals 8, y equals 15. In order to find my 6 trig functions, I have to find the value of r. So I'm going to say r equals the square root of 8 squared plus 15 squared, x squared plus y squared. R is going to equal the square root of 64 plus 225, which will then equal the square root of 289, which is a perfect square. R equals 17. So now I have my 3 values that I will plug in. So I'm saying the sine of theta is going to be y over r. So y is 15, r is 17. Cosine of theta is x over r. X is 8, r is 17. The tangent of theta is y over x. So y is 15. X is 8. The cosecant of theta is going to be the reciprocal of the sine, so that's just going to be 17 over 15. The secant of theta, just going to flip cosine, 17 over 8. And the cotangent of theta, I'm going to flip tangent and have 8 over 15. So the only math we are really doing is finding our missing value. In example 2, the terminal side passes through -3, -4. Find the 6 trig functions. So just like the last one, but this time I'm going in the counterclockwise direction. I'm going to pass through -3, -4. I'm on the bottom here. This is technically my negative y-axis. That's my positive x-axis. So I went -3 units on the x-axis, and I'm going down -4 units on the y-axis. So I just need to find r. R is going to equal the square root of -3 squared plus -4 squared. -3 squared is 9. Negative 4 squared is 16. R is going to equal the square root of 25, which is 5. So, doing the same thing we did, the sine of theta is going to equal y over r. So y is negative 4. So it's going to be negative 4/5. Cosine is going to be negative 3/5. Tangent is going to be negative 4/3. Cosecant, just flipping, negative 5/4. Secant is going to be negative 5/3. And cotangent will be, this is positive, tangent's actually positive. Cotangent's going to be 3/4. Tangent is positive because x is negative and so is y. So your tangent and your cotangent in this case is positive. Example 3 is find the 6 trig functions if the terminal side is defined by this equation. So when you are given an equation, first thing you want to do is put it in y equals mx plus b, if it's not already. So we're going to put it in slope-intercept form. So x plus 2y equals 0. I'm going to subtract x from both sides. 2y equals negative x plus 0. Divide by 2. Y is going to equal negative 1/2 x plus 0, which you don't really need to write the 0. From there, it tells me that x is greater than or equal to 0. So I need to pick any number bigger than 0 and plug it in for x in order to find a point. That'll give me my x value and my y value. So I'm going to plug in 2. We'll say x equals 2. You can pick any number. Y equals negative 1/2 times 2. 2's are going to cancel. Y equals negative 1. So I now know that x equals 2, y equals negative 1, and in order to find r, I'm going to take the square root of 2 squared plus negative 1 squared. And that is going to leave me with the square root of 5. Now, having that square root of 5, you know it's going to end up in your denominator. When that happens, a reminder from Algebra 2, you have to rationalize the denominator. So sine theta is going to be y over r. So it'd be negative 1 over the square root of 5. And to rationalize, I'm going to multiply numerator and denominator by the square root of 5. That will then give me negative square roots of 5 over 5 for sine. Cosine, I'm going to have 2 over the square root of 5. Again, rationalizing. 2 square roots of 5 over 5. Tangent, the one where we don't have to rationalize, be y over x, so it's just negative 1/2. You should be like, that looks familiar. Tangent is the same as your slope. Y over x, y over x. So tangent correlates with slope. Everything is going to start to tie together when we move on through this school year. When it comes to your reciprocals, don't flip this. This is going to get messy. Go ahead and flip your original. So negative square root of 5 over 1, or just the negative square root of 5. Secant, flip my original, square root of 5 over 2. And then cotangent is just going to be negative 2 when I flip that 1/2. So that's for when you are given an equation and you are asked to find your 6 trig functions. Last thing in this section is quadrantal angles. We kind of mentioned them back in section 1. They're your angles that end up on your X and Y axis. So here we have 90 degrees. Here we have 180 degrees. Down here is 270. And over here you have 0 and 360 degrees. So these are going to relate to the unit circle, which we don't really talk about until a later section. But at each of these points, your unit circle is a unit of 1. So at 90 degrees, its coordinate point is 0, 1. 180 is -1, 0. 270 is 0, -1. And 0, 360 is going to be 1, 0. So those are your quadrantal angles, and those are the coordinates that go with them. Those will never change. So 90 degrees, my point at 90 degrees is 0, 1. So that means X is 0, Y is 1. When I go to find R is going to equal the square root of 0 squared plus 1 squared. So R is going to equal the square root of 1, which is 1. Square root of 1 is 1. It's a perfect square. So the sine of 90 degrees, I'm now knowing my angle instead of it being theta, would be y over r, which is 1 over 1, which is just 1. The cosine of 90 degrees is going to be 0 over 1, which is 0. And the tangent of 90 degrees is going to be 1 over 0. And some bells should be going off in your head. You divide by 0, you put a hole in the earth, a black hole appears in the mathematical world. So 1 over 0 is actually going to be undefined. So UNDEF is how I simplify that. Cosecant of 90 is still going to be 1. That's not changing. Secant of 90, again, we're going to have 1 over 0. So that's going to be undefined. So tangent and secant are undefined. And then the cotangent of 90, we're going to flip that back around. 0 over 1 is going to be 0. Okay, so for 90 degrees, secant and tangent are undefined. That means that when you go to graph them, they're not going to touch a line. It is undefined on that point. There's no point for it. And lastly, an angle theta in standard position with terminal side passing through -3, 0. So x equals -3. Y equals 0. R is going to equal the square root of -3 squared plus 0 squared. So R is going to equal the square root of 9, which would be 3. Finding the 6 trig functions for that, sine of theta is going to be y over r, which is 0 over 3, which is just 0. Cosine theta is going to be x over r, so that'd be -3 over 3, which is going to be -1. Tangent theta is going to be y over x, so 0 over -3, which is just 0. Cosecant, since that 0 is going to be on the bottom, it's going to be undefined. Secant is still going to be -1. And cotangent is going to be undefined. So in this case, cosecant and cotangent were both undefined. There's a chart in your book. It's called Function Values. I'm not sure on what page it is on, but it is function values of quadrantal angles, and there's a nice little chart. It has 0, 90, 180, 270, and 360. If you want to copy that in your notes, and I will give you a note card when I do see you in class to make it. That is going to be a note card that you can use. Your homework for this section is page 28, 12 to 30 even. And 64 to 74 even. If you have any questions, don't hesitate to ask.